Alright, the function y is equal to x minus 4 squared times x minus 7 times x plus 3 cubed is negative on the intervals. So we have a series of intervals. What I want to do here is, let's create a sketch here just by looking at the order of the function, right? So I'm just going to create a generalized sketch just by looking at the roots and their respective behaviors. Okay, so I'm going to plot my roots here. We have the roots are going to be 4 and 0, right? Because if our function here is x minus 4 squared, x minus 7, x plus 3 cubed, right? If I let f of x equal 0 to find my x-intercepts, then you have the points 4 and 0. So you're just letting each factor equal 0, right? Whoops. You're just letting each factor equal 0, right? 7 and 0 as well as negative 3 and 0. Okay, so now that we have that, we're going to have a point 4 and 0, right? Let's say that this is 4 and 0. We're also going to have a point negative 3 and 0. Let's say it's like here, right? You know what? Let's make that closer to the origin. So let's say this is negative 3 and 0, right? And we also have 7 and 0. So I'm not doing this to scale, right? So it's not too important to look at this per scale, but I just want to look at the behavior. And if I look at these roots and I want to assess their behavior, let's also look at their order. Okay, so the root for 4 and 0, right? You can see that the function here has an order of 2, right? So because there's an order of 2, it's going to be concave to that point, right? So it's going to be concave to that point. We also know that our root negative 3 and 0, we're going to have a cube, right? So this is going to have an order of 3, and this is going to be a point of inflection to that point. The last point, 7 and 0, it's an order of 1, so it should pass through that point. Okay, so it passes through this point. Now, we also understand here that if I'm looking at the leading term, right, we have an x minus 4 squared, x minus 7, and x plus 3 cubed. Your leading term here is going to be x squared times x to the power 1 times x cubed. Okay, so this is x to the power 6. So this should be an even degree function. A seems to be positive, right? So a should be 1 here, right? So a is greater than 0. So this is a positive even degree function. So because it's a positive even degree function, you should expect that the end behavior should be in quadrants 1 and quadrants 2. So the end behavior should be out here, okay? And let's look at the order and just kind of construct this really quickly, right? So we can understand that it's going to pass through 7. So I'm just going to draw the trace in a different color. And it's going to pass to 7. So it should kind of go through there, right? At 4 and 0 it should be concave to this point, and at negative 3 and 0 should be a point of inflection. Now the end behavior should start off here. Okay, so it's going to pass through this point. It's going to be concave up, and then it's going to be concave down. Now, what you could help to define the sketch, I'm going to find the y-intercept really quickly. Okay, so if I'm finding the y-intercept, I'm doing f of 0, which is 0 minus 4 squared times 0 minus 7, 0 plus 3 cubed. And this is going to give me negative 4 squared times negative 7 times 3 cubed, which is 16 times negative 7 times 27. So I'm just going to punch this in my calculator. It's about negative 3024, right? So it's going to be like a really low term, so it's not too important. We don't need to really make a refined sketch, right? We can notice how all of this kind of comes together. And essentially what's going to happen is we should have a concave down portion here and then a concave up portion here. Now the reason I drew the sketch is because it's really easy to look at the intervals now. Okay, so you can notice that the negative intervals are going to basically be all of this region here, right, as well as this region here. Okay, so a negative interval will include negative 3 and 4 union 4 and 7, right? So this would be like 7 and 0, right? So this would be 4 and 7, right? So the best answer in this scenario here would be D.